Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. EtLi is a strong organolithium reagent. When a carboxylic acid reacts with organolithium reagents, the reaction proceeds stepwise. Moving on to the next step. The first equivalent of EtLi deprotonates the carboxylic acid or pK-5 to form the carboxylate salt RCO2Li+. This consumes one equivalent of EtLi, producing ethane gas. Moving on to the next step. A second equivalent of EtLi adds to the carboxylate to form a dilithiated tetrahedral intermediate, dianiene. This requires one more equivalent of EtLi. And for the final step, the substrate also has an alcohol, or group. The third equivalent of EtLi deprotonates the alcohol, or protecting it as the lithium alkoxide and preventing side reactions. So with three equivalents EtLi, 1,1 deprotonates Cu, 1,1 deprotonates O, 1,1 adds to the carboxylate carbon nucleophilically. The note says 3.5 were used. The extra 0.5 ensures complete addition to the carboxylate. Upon aqueous workup, H+, H2O, the dilithiated tetrahedral intermediate collapses to give a ketone. The standard carboxylate plus Arley ketone pathway stops at ketone because the carboxylate dianiene intermediate is less reactive toward further addition under these conditions. The reaction of RCO2H with 2,8 Arley after deprotonation gives a ketone R-CoR after workup. Here the carboxylic acid portion is cyclohexyl-CH or CO2H, and EtLi adds to the carbonyl of the carboxylate. After workup, the CO2H becomes CoEt, a ketone, and the O is restored from the lithium alkoxide. Product cyclohexyl-CH or CoEt, which is an alpha-hydroxy ketone, the cyclohexene-bearing carbon retains its OH group, and the carboxylic acid is converted to an ethyl ketone. This matches option B cyclohexane ring with CH, or C is equal to O et. Why other options fail? Option A shows a 1,3 diactone, which would require to separate ketone-forming reactions or different mechanism not consistent with this substrate and reagent. Options C and D show alpha, beta unsaturated ketones, enones, which would require elimination. There is no beta-leaving group to form an alkene under these conditions. The O is on the alpha carbon to the acid, not beta. The extra 0.5 mentioned ensures complete conversion of the carboxylate intermediate to product, confirming the ketone, B, is formed cleanly. Therefore, the correct answer is B. Therefore, the correct answer is option B.